we are trying to solve a small problem based on surface tension. Let me read out the problem for you. Two soap bubbles of radii R1 and R2. The condition is the first radius is bigger than the second radius, are in contact. What's the radius of their interfaces? It's a kind of a question, right? Let me try to visualize what is given for you. This is soap bubble 1. This is soap bubble 2. They are in contact. This is what their interface means. He want the radius of this interface, right? It is given that this one is having a radius R1, this one is having a radius R2, and R1 is greater than R2. So, because this is so bubble having some surface tension T, because of the spherical drop formation, there is an excess pressure developed in each of the drop. We know the formula for excess pressure inside the bubble, so bubble is 4T by R, where T is the surface tension, R is the radius. So excess pressure in the first drop is 4T by R1, and excess pressure in the second drop is 4T by R2. As it is given that R1 is greater than R2 and R is in reverse, in reciprocal to the pressure is in reciprocal reverse. P2 is greater than P1. So the pressure difference between them is P2 minus P1. So when you say excess pressure P is equal to P2 minus P1, in the place of the pressure, I can use this formula. Imagining this interface is also having a radius. This combined drop is having some radius. It's also having some excess pressure. Excess pressure of that will be 4T by R, where R is the radius of that interface, is equal to P2 means we have already derived a formula, 4T by R2. P1 means we have already explained a formula, 4T by R1. So if you simplify both of them, all 4T's can be cancelled. 1 by the radius of that interface is equal to 1 by R2 minus 1 by R1. R1, R2 is the LCM. R1 minus R2 as for the basic mathematics, that's 1 by R. So the radius of that interface is R1, R2 by R1 minus R2. That's how we derive a formula for the radius of the interface, simply using a basic concept of excess pressure. That's it. Thank you for watching.